Nokia famously lost the smartphone era. For a generation, it was the most dominant mobile phone company. Its handsets defined what a phone looked like, felt like, and did before smartphones came along. Then the platform shifted. Apple won the premium market, Android won the mass market, Nokia became one of the great cautionary tales in technology. But Nokia did not disappear. The consumer business faded. The part that remained moved deeper into the infrastructure layer, telecom equipment, optical networks, IP routing, and the physical systems that move data around the world. For years, that looked like a much less exciting business. Then AI changed the shape of the outlook. The AI boom is usually told as a story about intelligence. OpenAI builds the models, Nvidia sells the GPUs, hyperscalers build the clouds. But once you have enough AI compute, the next problem is not only generating intelligence, it is moving it between GPUs, between data centers, across cloud regions and the edge. That is why Nokia is back in the story. Not because it is building the next ChatGPT or designing a GPU, but because AI has a networking problem, and Nokia is trying to sell parts of the nervous system. In this video, we are going to look at three main questions. First, how did Nokia transition from the company that lost the phone era to one selling the infrastructure behind the AI boom? Second, why is AI creating a massive new networking bottleneck, not just inside data centers, but between them? And why do optical systems, IP routing, and pluggables suddenly matter so much? And third, can Nokia actually compete against established specialists like Arista in switching and Ciena in optical? Or is it still a legacy telecom company trying to attach itself to the AI story? Let's unpack this. After selling its handset business to Microsoft in 2014, Nokia became something less visible, a network infrastructure company. That meant selling the equipment behind mobile networks, broadband systems, optical transport, IP routing, and the connections that allow data to move around the world. It moved from the thing consumers touched to the thing consumers never saw. It lost the screen, but it kept the pipes. For a long time, that was not a glamorous place to be. Telecom equipment is tied to carrier budgets, 5G cycles, and slow infrastructure spending. Under CEO Justin Hodard, Nokia has restructured around two main businesses. Mobile infrastructure is the traditional side, 5G radio equipment and the systems that power mobile networks. This remains the larger share of Nokia's overall revenue. Network infrastructure is the other side. Optical networks, IP routing, fixed networks, and data center interconnect, the part of Nokia now directly exposed to AI and cloud demand. The split matters for reading the story. Mobile infrastructure is the bigger business. Network infrastructure is the faster-growing one. And the reason it is growing faster has nothing to do with traditional telecom cycles. When a company like Microsoft or Google builds a new AI data center, it doesn't only need servers and GPUs. It needs to connect those data centers to each other and to the rest of the internet. Long-distance optical fiber, high-capacity IP routing, data center interconnect. These are the products Nokia sells through its network infrastructure division, and the companies buying them are increasingly not mobile operators. They're cloud and AI builders. Nokia is not selling into this market because it pivoted toward AI. It's selling into it because it already made the equipment the AI infrastructure build-out happens to need. And to understand why Nokia's specific products matter, you need to understand what AI actually requires from a network. By the way, if you want to track which infrastructure companies are being pulled into the AI economy in ways nobody expected, that is exactly what we cover every week in our newsletter, ARPU. If you want that kind of analysis in your inbox, subscribe at the link in the description. This is where Nokia's optical and IP networking businesses become relevant, and where a recent acquisition explains how Nokia is positioning itself. In 2024, Nokia acquired Infinera, one of the leading coherent optical networking companies, for approximately $2.3 billion. Infinera was not a general networking company. It built the high-capacity fiber systems that carry enormous volumes of data across long distances, the kind of equipment that connects data centers to each other and to the internet backbone. The acquisition effectively doubled down on optical at exactly the moment hyperscalers began spending heavily on data center interconnect. Nokia paid for depth in the specific product category that AI infrastructure needs. Here's why that matters. A modern AI training cluster is not one location. It's often multiple data centers trying to behave like one coordinated system. Data moves constantly between them, between storage and compute, between training and inference, between one cloud region and another. Connecting those facilities requires optical transport, high-speed fiber links that move terabits of data per second with low latency and high reliability. The faster the data can move between facilities, the more efficiently the AI factory runs. One product in Nokia's portfolio is its 800G ZR and ZR Plus coherent pluggables, high-speed optical modules used specifically for data center interconnect. Nokia has said its cloud and hyperscaler customers are deploying these to scale their AI infrastructure. At 800 gigabits per second per wavelength, they're designed for exactly the high-density, high-throughput connections that AI data centers require. A pluggable is not glamorous. It's a small module that converts data into light, sends it through fiber, and converts it back at the other end. But in a world where moving data fast enough is the constraint on AI performance, it's one of the components that determines whether a cluster runs at full capacity or sits partially idle. The numbers are starting to show why investors are paying attention. In the first quarter of 2026, Nokia's AI and cloud net sales grew 49% year over year. It booked 1 billion euros of AI and cloud orders in the quarter. Optical networks grew 20%. But those numbers need context. AI and cloud customers still represent only about 8% of Nokia's sales. The remaining 92% is still mostly Nokia's broader connectivity business, much of it tied to telecom operators and exposed to slower carrier capex after the peak 5G spending cycle. That gap is the central tension in the Nokia story. The AI and cloud business is growing fast. It is also growing from a small base. Nokia said it won multiple AI and cloud design wins in the quarter, including orders from hyperscaler customers for both coherent pluggables and optical line systems. These are the customers who matter most to the network infrastructure growth story, the companies building AI data centers that need to interconnect facilities at scale. The more revealing number is the trajectory. If AI and cloud were a small fraction of Nokia's revenue 2 years ago and are approaching 10% with 49% annual growth, the question investors are asking is not about today's revenue. It is about what Nokia's revenue composition looks like in 3 to 5 years if that trajectory holds while mobile infrastructure faces headwinds. Justin Hodard's argument is that AI is not just a compute story, it's a networking story. Compute and networking, he has said, live in a trade-off. Add more GPUs, and eventually the network has to keep up. That's why Nokia wants investors to look at optical not as boring telecom plumbing, but as one of the core bottlenecks of the AI build-out. The AI boom began with the question, who has the GPUs? Then, who has the power? Then, who has the data centers? Now, another question is emerging. Who connects all of it? That's where Nokia is trying to position itself, and the numbers, while still small, are starting to move in the right direction. Then, Nvidia showed up. In October 2025, Nvidia announced it would invest $1 billion in Nokia, not as a passive financial bet, but as a strategic signal. Nvidia sees AI stack extending beyond the chip into the network that connects chips together and the software that manages that network at scale. The partnership has 2 layers. The longer-term layer is AI RAN. Traditional mobile networks run on purpose-built hardware. AI RAN changes that. The radio access network software runs on GPU-accelerated infrastructure instead of proprietary telecom equipment. Nokia has been conducting trials with operators in North America and Europe. The commercial timeline is measured in years. This is not a near-term revenue story. But if it matures, mobile networks themselves become a workload running on shared GPU infrastructure. The more immediate layer is data center networking. Nvidia has built Spectrum-X, an Ethernet networking platform designed specifically for AI data centers, where thousands of GPUs need to communicate with each other at high speed and low latency. Standard Ethernet was not built for this kind of traffic pattern. Spectrum-X addresses that problem. Nokia's contribution to the architecture is SR Linux, its network operating system, which manages how traffic moves through large-scale data center networks. Nokia already runs SR Linux at major hyperscalers, so it's not pitching an untested product, it's offering software the data center operators already deploy. Nvidia builds the GPU cluster, Nokia helps run the network around it. That's why the investment matters. The GPU is still the center of gravity, but as AI systems get larger and more distributed, the network connecting them becomes harder to manage, and that's the gap Nokia is trying to fill. Nokia is not the only company targeting the network infrastructure underneath AI, and in most layers it's competing in, there's already a more established player. In optical, Ciena has been selling coherent optical systems to hyperscalers for years. It has the installed base, the customer relationships, and the singular focus that come from doing one thing for a long time. Nokia's Infinera acquisition gave it scale in coherent optics, but Infinera was Ciena's competitor before it became Nokia's acquisition. Nokia has the assets. Whether it can match Ciena's execution in a market where hyperscaler purchasing relationships are already established is a different question. In AI data center switching, Arista is the more proven name. Meta, Microsoft, and other hyperscalers have deployed Arista switches at scale for years. Its network operating system is considered best in class in that environment. When a hyperscaler engineer designs a fabric for thousands of GPUs, Arista is the default reference point. Nokia's SR Linux is interesting in the Spectrum-X context, but interesting is not the same as proven. Cisco competes for the same enterprise customers, Ericsson fights Nokia directly in mobile infrastructure, and Huawei remains a genuine global-scale competitor in both optical and telecom. Nokia is not clearly ahead of any of these companies in their strongest market. It came to coherent optics through an acquisition, it entered AI data center networking as a software partner, not the primary vendor, and AI RAN remains a future thesis that commercial deployments have not yet validated at scale. Nokia's story probably boils down to a breadth argument. None of its competitors cover the full stack. Optical, IP, fixed networks, telecom software, and AI RAN networks. If AI networking stays narrowly concentrated in data centers, Nokia will spend the next several years fighting better-positioned specialists on their own ground. If AI spreads across telecom networks, edge locations, and enterprise campuses, Nokia's breadth becomes harder to replicate. That's a reasonable hypothesis, and Nokia is trying to prove it while managing a large legacy telecom business at the same time. So where does that leave us? Nokia is not the brain of AI, and it's not the face of it, but it may own part of the network the intelligence has to travel through: optical transport, IP routing, pluggables, telecom software, and eventually AI-native networks. Whether Nokia can execute against better-positioned specialists in each layer is still to be proven. Nokia lost the device era. This time, it's trying not to lose the network era. And the next question is how you value a legacy infrastructure company with a fast-growing AI business inside it, and whether the market is pricing that correctly. That is what we break down every week in our newsletter, ARPU. If you want that kind of analysis in your inbox, the link is at the top of the description. Thanks for watching.